how to find max and min of f of x comma y, function f of x comma y. First, the procedure to find this thing is, consider the value r is equal to dou square f by dou square dou x square. Just remember this thing. S is equal to dou square f by dou x dou y. T is equal to dou square f by dou y square. Just remember r is equal to dou square f by dou x square, comma s is equal to dou square f by dou x dou y, and t is equal to dou square f by dou y square. These three things you have to keep in mind. Now, the conditions for finding the maximum minimum. If rt minus s square is greater than 0 and r less than 0, that means dou square f by dou x square into dou square f by dou y square minus dou square f by dou x dou y whole square greater than 0 and dou square f by dou x square less than 0, then we are going to have maximum. And same thing, if rt minus s square greater than 0, and we have to consider this thing for maximum and minimum. For both the things, rt minus s square must be greater than 0, and r must be positive. That means dou square f by dou x square is positive. Then we are going to have minimum at that function at that point. And these are extreme values, saddle points, and that we don't want. Yeah, I'm just directly considering a function f of x comma y is equal to x power 4 plus x power 4 y power 4 minus 2x square plus 4xy minus 2y square. I'm finding the dou square f by dou x square first, then dou square f by dou y square, then and dou square f by dou x dou y, then it's r t s. Then I'm going to consider the given conditions that we discussed above. Fx, that means dou by dou x of f is known as fx. Dou square f by dou x square is written as fxx. See, consider the whole function respecting partially differentiating with respect to x. That means we are treating y terms as constant, and differentiation of constant with respect to any variable is going to be 0. And dou f by dou x is turned out to be 4x cube minus 4x plus 4y. Dou f by dou y is turned out to be 4y cube plus 4x minus 4y. R is equal to, I am differentiating again with respect given function with respect to x, partially differentiating with respect to x. I am differentiating this function with respect to x, and I am going to get it. I am differentiating this thing, and I am going to get this thing. I am partially differentiating this thing with y. I am going to get this thing. Now I have to differentiate this function with respect to y, or this function with respect to z, with respect to x, to get s. That's what I have written. And now we have to consider the conditions. rt minus s square. We found out r, s and t now, and we have to go further reduction. Adding these, we get 4x cube plus y cube equal to 0, or y is equal to minus x. What we got? We are adding dou f by dou x plus dou f by dou y, and we are equating it to 0. Just wait for a while, then we are going to get the answer. 4x 4 into, or y is equal to minus x. If we keep this y equal to minus x in 1, that in the sense, given x cube minus x plus y equal to 0, then we are going to get the values of x as root 2 comma minus root 2 comma 0. Corresponding values will be, if you take x equal to minus y, we got x values as root 2 comma minus root 2 comma 0. Then we are going to get y values as minus root 2 comma root 2. The points will be x comma y is equal to root 2 comma minus root 2 minus root 2 comma root 2 comma 0 comma 0. These are the points where we have to find the values of r, t and s, and we have to check whether it is greater than 0 or not. Yeah, at root 2 comma minus root 2, rt minus s square, we are evaluating rt minus s square, it's turned out to be positive and it's greater than 0. R is positive, hence at f of root 2 comma minus root 2 we have minimum value of the function. At now I am considering another point where x comma y is equal to minus root 2 comma root 2. At that function both rt minus s square and r are positive, so we are going to have minimum value at both the points. Yeah. Now we studied about how to find the maximum and minimum of a function with variables x comma y.